Today we'll be going over systems of equations solving with substitution method. In the substitution method, we substitute in an equivalent expression for one variable into one of the equations. The steps follow as such. Solve one of the equations for one variable. Substitute the equivalent expression into the other equation and solve for the remaining variable. And then our last step is to substitute that value of the solved variable into the first equation and solve the remaining variable. This is one of the longer written processes, but it makes it easier and you don't need to use a calculator for a majority of the math. Using these steps to kind of explain it as the process that it is. Step 1, it says solve one of the equations for one of the variables. In example 1, it already given us a variable by itself. We have the equation that says y equals 3x. Make sure I use the same equation by having a lowercase y. So in this case, my very first step, I don't have to do anything else. It's already set for me. I just had to choose which equation I wanted to use. My next step, step 2, is substitute in this equivalent value. I want to replace y in my second equation with 3x. The way we go about doing that is, first we write down which equation we are using. So if you look, my first equation, the one that I wanted to use first, and my second equation, both of my equations of the system are shown at the top of these first steps. This is a good indication that you are using the steps properly. Now what I want to do is I want to replace my y with its known equivalent value 3x. Oops. Kind of jumping all over the place there. Want to make sure that it's a lowercase x. And now instead of my y, I'm replacing it with its equivalent expression, 3x. And it still equals 8 to finish the equation. So all I did was take the equivalent value of 3x and replaced it with the variable. The reason why we do this is now we have an equation with only one variable in the equation. From here, we can solve. First, we have to simplify. X plus 3x is 4x, and it still equals 8. Now we can solve where we divide both sides by 4, and we find out that our x value is equal to 2. So we replaced our y value with its equivalent expression, which gives us all one variable. This allows us to solve one variable for a value. Now to connect this back with the first problem, our first equation, I will rewrite the first equation. And now I will use this known value x in this first equation. This is why we jump back and forth and make sure that we use all of the equations in the system to make sure that the values match up. So in this case, we have y equals 3. This time, the variable value that I'm plugging in is multiplied to a number. So I want to make sure that I use parentheses so I can properly plug in the value. This says 3 times x. Now I'm showing 3 times 2, the equivalent value. Also making sure that the variable stays correct. My last step is to simplify. 3 times 2 ends up being 6. So now I have a value for x, and I have a value for y. I don't need to make it bigger than the other one. There we go. X value was 2. My y value is 6. So the solution for my system of equations is 2, 6. What this means is if I used a graph, the point of intersection of these two lines would be at the location 2, 6. Or if I was looking at a table at x value 2, both my equations, y value would end up being 6. That's going back to our last lesson, going over solving equations, system of equations with tables and graphs. Now, we're not always going to have it to where one variable by itself. We'll have to choose an equation and then solve for one variable. I marked down the second one to show that I don't have to use the very first equation right away. No other reason. You can choose it how you want, as long as you can easily get a variable by itself. Now I'm going to solve for x so that I don't have to worry about dividing by anything. One reason why you would want to do this is so that you don't have to worry about any fractions in your work. In this case, I would just subtract 4y from both sides. And then I am done for the first column. I picked an equation and I solved for one variable. One of the reasons why I chose to solve for x. In the second column, I need to write the other equation. So since I chose the second equation, I need to use the first equation. I solve for x, so I'm going to replace x. Because it has a coefficient, I need to show that I am multiplying by the equivalent expression. And I still have plus y equals 9. Now that I plug this equivalent expression in, I can distribute to start the simplification process. 2 times negative 4y is negative 8y. 2 times 1 is a positive 2. And then the rest of my equation was the plus y equals 9. I can still simplify. I have my variable on the same side. This means I can combine like terms. I get negative 7y plus 2 equals 9. Now I'm down to a two-step equation. I have a constant and a coefficient. I want to subtract both sides by 2. Subtract by the coefficient, or the constant, sorry. You want to subtract by the constant. And then you want to divide by the coefficient. This leaves us with y equals -1. We have a value for the y variable. Jumping over into our last column, just like our first problem, we go back to our very first line. This time we have a value for y, so I can replace my y with -1. Because it has a y as a coefficient, I need to show that I'm multiplying by the -1. My next step, I need to simplify. I can multiply the +4 with a -1. This gives me x minus 4 equals 1. And then my last step, adding 5 to both sides. I get I'm sorry, not adding 5 to both sides, adding 4 to both sides to get x equals 5. There we go. That sounds a lot better. Now I have a y value and an x value. If I were to plug this into both of these equations, it would come out to be true statements. So to show my answer, the solution is 5, -1. Now, just like when we were solving systems of equations with graph and tables, there are situations where we can have no solution. For the graph, the lines never touched. For the table, there were no values of y that matched at any x value. For substitution method, what happens is, in your second column, after you solve one equation for one variable and plug it in to the other equation, you end up canceling out your variable. In this case, I had -4x plus 4x. When I combined the like terms, they canceled out. This left us with -2 equals -4. This is a false statement. This goes back to one of my earlier lessons. Whenever we are left with a false statement, that means there is no solution that would make our system true. There is no one solution or any solution that will make our statement true from the equations. And then on the other hand, if it does come out to be positive, when we canceled out 6x minus 6x to get 0x, just cancels out, we get a true statement. This means infinite solution. That means any combination of x and y in one equation will match the second equation. All of them are going to match up. This would be our lines overlapping on a graph, or all of our table values being the same between both equations.